Try this again. Okay, so starting today, continuing in chapter 5, we are working on graphing a line. So last week, we talked about graphing a line using the slope and the y-intercept. Okay, that was when we talked about y equals mx plus b equation. That's called point slope form. Okay, so there's a couple of different ways to graph a line. So versions of a line. Versions of a line. Okay, the one we learned last week was y equals mx plus b. Okay, versions of a line. So y equals mx plus b, that is actually, it has a name, okay, and that one is actually called, excuse me, it's actually called slope-intercept form. This is what's called slope-intercept form. Slope-intercept form. Okay, this is the way that we usually like to graph lines. It's just the easiest usually. Okay, but there's a couple other ways that we can graph a line. Okay, another way that we could graph it is something called point slope form. Okay, and point slope form we will deal with, I'm not sure if it's today or tomorrow, so I don't want to tell you the wrong way. We're going to deal with it tomorrow. Okay, but today we're dealing still with slope-intercept form. So today we are going to graph a line using intercepts. Graph a line using intercepts. Graph a line using intercepts. So, can anyone tell me, what does the word intercept mean in math? What is an intercept? If I said, like I intercepted you, what would that mean? You like ran into, okay, or like crossed, okay? Like if I say you hear about this kind of a lot of times in like if you ever see on the news and they're talking about like especially when we talk about war, okay? Like people say, oh, they were intercepted. Okay, so that means they were captured, they were crossed. We've crossed paths with someone and they captured them usually, okay, or they caught them, okay? Or a lot of times, like if you hear a news story about like the police, they intercepted a suspect, okay? They caught them, basically. In math, intercepts are talking about generally the y-intercept and the x-intercept. So, first off, what is this side-to-side axis? Is this the x-axis or the y-axis? That's the x, okay, so the side-to-side one is the x-axis. So that means the up and down one is the y-axis. Okay, x-axis and and y-axis. That's always a tongue twister for me to say. So, if a line, wherever a line crosses the x-axis, this would be called its x-intercept. Okay, if it crosses the x-axis, and it could be on the positive side or the negative side, doesn't really matter. This is called the x-intercept. So it's where the line crosses the x-axis. That's an x-intercept. What do you think it's called where a line crosses the y-axis? A y-intercept, exactly. So x-intercepts and y-intercepts, okay? So it could cross the y on the negative part or on the positive part. Does not matter, okay? But wherever a line crosses the y-axis is called its y-intercept. Wherever a line crosses the x-axis is called its x-intercept. So last week, we started talking about this version right here. Okay, and we talked about how you begin our line. We put our first point at the B, and the B stands for what? The B, it stands for where it begins, but where do I put this? What's another word for B? It's where it begins, but it's also a y-intercept, right? So we always put our first point at the y-intercept, so the up and down. Then the slope, the M, tells you what? How to do what? How to move, right? We are going to deal with different kinds of lines today, okay? We're going to draw them, between two intercepts. So whenever you're trying to draw a line, you just have to have 2 points. Okay? Once we have 2 points, we can draw them, we can connect them with a line. This one, this is what we're going to do today. We're going to connect things with 2 dots and make a line. So instead of using just the y-intercept and the slope, we're going to deal with 2 intercepts today. So it's just another way of graphing lines. So if I ask you to, let's see, let's start on some examples. So first thing we're going to do is state the x and y intercepts state the x and y intercepts of, and I'm going to give you the equation of y equals 2/3 x. My pencil's killing me today. Y equals 2/3 x minus 2. State the x and y intercepts. So, state the x and y intercept of y equals 2/3 x minus 2. 2/3 x minus 2. So, there's 2 different parts here. Okay? Immediately, can you tell me what is the x or the y intercept? Can you tell me, just based on this equation, what one of the intercepts is? Caroline?
The y-intercept is -2.
We know that the y-intercept is -2 because when this is written in y equals mx plus b form, which this is, remember, hopefully you remember that this is the slope and this is the y-intercept. Okay, we use those as where you begin and how you move, but this last number here is the y-intercept. So here, automatically, I can read this as the y-intercept. How would I write that as a point? Remember, as a point, we always write things as what? X, then y. So where should the -2 go? In the first spot or the second spot? The y-intercept should go here. What should go at the x part? What is the x if it's where it's crossing? Holly? 0, right. So here, we know that my y-intercept is going to be 2. That means the x part has to be 0. Yes, Chantal? Sure. So, first thing we can do is we can draw our y-intercept. So, is the x, or excuse me, is the 0, -2, is that going to be up 2, down 2, left 2, or right 2? Where is 0, -2? Down 2, okay? Remember, this is the y-axis, this is the x. This 0 always tells you move over 0, so the first number is the side-to-side movement. The second number is the up or down movement. So if we wanted to graph this at -2, you would put a point at 0, -2, so over 0, down 2. Okay, that's your y-intercept. From there, we also need to find the x-intercept. Okay, to do that, we plug in 0 for y. Okay, so I'm going to show you how we find x-intercept. Okay, so to find y-intercept, look at equation. To find the y-intercept, look at the equation and identify b value. Okay, so to find the y-intercept, we look at the equation, identify the b value, and the b value is what's called your y-intercept. Okay, to find x-intercept, plug in 0 for y and solve. Okay, so to find the x-intercepts, you plug in 0 for y. To find the y-intercept, we technically plug in 0 for x. But if it's written like this and you plug in 0 for x, isn't it basically just doing that? Y is -2, right? So it's easier. We don't really have to plug anything in. It's easier to just look at it. Okay, once it's in y equals mx plus b form. To find the x-intercept is a little bit more difficult. Okay, so to find the x-intercept, what would we have to do here? Any ideas? What would we have to do to find the x-intercept? Plug in 0 for y. So I'm going to rewrite this with 0 equals 2/3 x minus 2. And then I have to solve. How would I solve that? Not yet. Add the 2, right? So add 2 to both sides. This is going back to what we did in our last unit. You add 2 to both sides, we'd get 2 equals 2/3 x. Now how do I solve? How do I get rid of a fraction? Multiply by the what? Reciprocal, right. So what's the reciprocal of 2/3? 3/2. So multiply both sides by 3/2. Multiply both sides by 3/2. These go away. So we get x equals, what happens here? The 2's can cross cancel, and all you're left with is a what? A 3. So if I wanted to write this as a point, how would I write that as a point? 3 goes in the x spot. What goes in the y spot? 0. Okay, when you're finding intercepts, one of the parts is always going to be 0. So this would be your x-intercept. So if I wanted to graph this, my x-intercept is at 3, 0. Where is 3, 0? Does the 3 tell you to go up, down, left, or right? Right, 3, and over, and up and down how many? 0. This is your x-intercept. Okay, so your x-intercept is at 3. Your y-intercept was at -2. And then you take the 2 and connect them with a line. That is graphed. Okay, this is a horrible pencil, sorry. So that is graphing using intercepts. Okay, we're going to practice a bunch more. But graphing using intercepts means we find 2 points and then graph. Okay, find 2 points and then graph. Gentlemen, not right now. Yes, ma'am. So find 2 points and then graph. Sorry, this was number 1.
Back up.
It'll become a lot easier as we move on, I promise.
That's the equation.
Uh-huh. Just letting a couple of you guys catch up and then we'll move on. Done, Amber? You still going?
Do I have to like write those letters? I mean those letters. Those numbers.
Man, you guys are bad at notes today. Just so you guys are aware, on our next unit test, you will have a 100-point quiz based on your notes as well. Because I'm a little concerned that a lot of you are not taking good notes. So you will have a quiz based on your notes. It will be open note, but it's going to be on your own. So you better be taking notes and doing them well. If I write it down, you should write it down. It's going to be 100 points. Right before we take our test. So the quiz will be on your notes right before we take the test. In 2 weeks, yes. 2 weeks. Okay, next thing we're going to do. So we're going to do the exact same thing. I'd like you to state the x and y intercepts. So for number 2, state x and y intercepts.
Is this Is this example just like number 1?
Yes. So state x and y intercepts and graph. Okay, state the x and y intercepts and graph. Y equals negative 1/3 x plus 5. So let's start with our y-intercept. Okay, to find y-intercept, let's write ourselves a note. Plug in 0 for x. Okay, so to find y-intercept, we plug in 0 for x. To find x-intercept, you plug in 0 for y. So you plug in 0 for the opposite letter of what you're trying to find. So for y-intercept, plug in 0 for x. So that would give you y equals negative 1/3 times 0 for x plus 5. What happens when I do negative 1/3 times 0? You get 0. So y equals 0 plus 5. So what is your y-intercept? 5. And how do I write that as a point? The 5 goes in which spot? The first one or the second one? The second one. And the first spot is a 0. Now, the first one I showed you was a little bit easier than that. Okay, if you're finding a y-intercept, you can just plug in 0 for x. So that basically means in my equation, I could have just covered it up. And y would equal 5. Okay, that one's like super basic. That one's really easy. You don't really have to do much math there. So you can just cover it up. Unfortunately for the x-intercept, it's not quite that easy. Because if I cover up this side, it doesn't really tell me exactly what it is. So to find the x-intercept, it's a little bit more difficult. Okay. X-intercept, plug in 0 for what? For y. We plug in 0 for the opposite letter. So 0 equals negative 1/3 x plus 5. How would I solve from there? How do I solve from there? I'm trying to solve for x. Move the 5, right? So subtract the 5. 0 minus 5 leaves you negative 5 equals negative 1/3 x. Then how do I get rid of a fraction? Use the reciprocal, the multiplicative inverse. So what's the reciprocal of negative 1/3? 3 over 1. And you do have to keep the negative. Okay, so if the number starts as a negative, its reciprocal is negative. So multiply both sides by negative 3 over 1. On this side, negative 3 times negative 5 gives you what? 15. Do I have to write over 1? Not really. Okay. Equals, and what happens here is these will cross reduce. So 15 equals x. How do I write that as a point? Because an x-intercept is a point. So 15 go first or second? 15 is first, comma, 0. Then if I want to graph this, make a graph. Okay. Do your best. You don't have to put 15 little spaces. Okay. We can say that on the side to side, it could be worth 1 each. So 1, 2, 3, 4, 5. Okay. You could say that these are worth what? What would I want to make?
5, 3.
These are worth like 3 each. So 3, 6, 9, 12, 15. If you label it, that's fine. I don't need to see 15 little spaces. And on the y, I would go 1, 2, 3, 4, 5. Okay? So if you label it, that's fine. So I'm going to label this, say that it's 5. Okay? I'm going to label this, say that it's 15. As long as it's labeled and it's reasonable, that's fine. Okay? Like you couldn't make 15 super close and 5 super far. That doesn't make sense. Okay? But label these and then connect the two lines with, or excuse me, connect the 2 points with a line. And most of the time when you're drawing these, like on your homework, when you're drawing these, there's going to be graphs drawn for you.
I get the graph part, but this part, I don't get it.
Okay, well, we're still going. We're still going. Okay, let's try another one. We're going to do, do you guys feel good about the graphing with the intercepts? Or do you want to do one more like that? You feel good about that? Okay, let's try another something. Okay, let's try something written in a little bit different form. Okay, I want you to do the same thing. We're going to state the x and y intercepts in graph for example number 3, but this time I'm going to write it in a little different form. Okay, this one's going to be called standard form. Okay, standard form is when something's written in ax plus by equals c form. And what this means is standard form means the x and the y are on the same side. X and y on same side. And there's also no fractions. Sorry, I ran out of room there. Okay, so standard form is when you have x and y on the same side. It doesn't really matter to me that you know the names of the different forms. You just need to know that there are different forms. Okay, so this one just means that you have the x and the y on the same side. What we're used to seeing is what form? Do you remember what form we were used to seeing? Y equals mx plus b is what form? It's called slope-intercept form. Okay, slope-intercept form. I'll write it up here. Slope-intercept form. Slope-intercept form is when you have y equals mx plus b. Okay, so that just means y is by itself in slope-intercept form. Standard form is when x and y are on the same side. That's the difference between the two. Got that written down? Okay, so for number 3, I want to start by, let's say that this is going to be a word problem, okay? If I tell you the drama department, I just lost my part, sold $1,260 worth of tickets to a play. The drama department sold $1,260 in tickets to the play. Okay, if I tell you that student tickets cost $5 and adult tickets were $9. This is represented by the equation. Thank you. This is represented by the equation. I lost my place. 5x plus 9y equals 1260. I want you to use x and y intercepts to graph the equation. Then interpret intercepts. Don't worry, you guys won't have to write the words on your homework. Okay, so the drama department sold $1,260 in tickets to the play. Student tickets cost $5 and adult tickets cost $9. This is represented by the equation 5x plus 9y equals 1,260. Use x and y intercepts to graph the equation, then interpret intercepts. So we're going to interpret the intercepts. So what do they mean when they cross? Okay, but the first thing we want to do is actually do the graphing. So if I gave you this equation, this one's written in standard form, which just means that it has the x's and y's on the same side with no fractions. Okay, how do I find the x-intercept and the y-intercept? How do you find the x-intercept? Plug in 0 for opposite letter, which is y. So plug in 0 for y. So that would be 5x plus 9 times 0 equals 1260. So this goes away basically. So we got 5x equals 1260. How would you solve for x? Divide both sides by 5. I'm going to let you guys do that on the side of your paper and tell me what x equals. So do 1260 divided by 5. What do we got? 252? Anyone disagree? So we got the same thing? You're fine. Go ahead and sit. We're in the middle of the notes. So 252. So if I was going to write that as a point, how would I write that? 252 comma what? 0, because that's in the x spot. Now I want to find the y-intercept. Okay, let's find the y-intercept. How do I find the y-intercept? Plug in 0 for what? For x. So 5 times 0 plus 9y equals 1260. That basically cancels that out. So we got 9y equals 1260. So y will equal what? We divide both sides by 9. What do we got for y? 340? 140. I was like, I don't think that works. 140? So my y-intercept would be what point? 0, comma 140. Okay. Now if I'm going to graph this, obviously this graph is going to have like, I'm not going to write out 140 little spaces. Okay. I'm not going to write out 252 little spaces. Okay. This would be, like if you saw the graph, actually, do I need all 4 parts here?
No.
Do I need any of these negative parts?
No.
No. So really, I can make this graph a little easier. I don't need all those negative parts. I just need the positive parts. So I'm going to write it like that, okay? Because that's going to look a little easier for me. So if this is your x and this is your y, about how many units would you want to make each space? About 50, because I need to go to 250, 252. So if I said like this is 50, then 100, 150, 200, 250. Sorry, I'm gonna have to move my little x a little bit. About how many apart when I want to make the y? So I have to go to 140. You want to do 50 again? Can we do 50 again? 40 wouldn't quite work because that'd be a little bit in between. But we could do 50 again. So like 50, 100, 150, 200. That would work, right? So if I'm going to graph these, the x, 252, comma 0. 252 is just a little bit barely beyond 250. Okay, just barely beyond. Doesn't have to be perfect. Okay. And then 140 is right below 150. So we agree that that's right below 150. And then I would label these. So that's 140, and this is 252. Then this line, connect the two. Would your line continue to go past here? Like, should I make it into the negative? No. Why would it not make any sense to be negative? Because we're talking about tickets. Can you sell a negative number of tickets? No. Okay. So it only goes from here to here. So what does this 140 tell you? So it says interpret the x-intercepts. Was the 140 for the student tickets or the adult tickets? The 5 was for students, and it went with which variable? Which letter? X or Y? Where did the 5 go? With the X or the Y? The X. So that means it was what? My x-intercept was at 252. So what this tells you is 252 is the number of student that could attend. The maximum number of students that could attend. So what that means is if they only sold student tickets and they still made that much money, that would have meant there was 252 students that were there. Okay, that would be the maximum number of students that could have attended. What is 140? Maximum number if they only sold adult tickets. Okay, this is maximum number if only adult tickets were sold. That would be the maximum number if only adult tickets were sold. Okay, that's what that means. Does anyone have any questions? No, you think you're good? Okay, what you guys are doing today is you're going to work on numbers 1 through 7. You're working on, homework is going to be page 213. You're doing number 213. Numbers 1 through 7, as well as 10 through 15. Okay, page 213, numbers 1 through 7, and 10 through 15. Okay, make sure you write it down, please.